Hi everyone, and welcome to 6th grade math. Today we're going to talk about moving from arithmetic to algebraic expressions, mainly reading and writing expressions in which letters stand for numbers, which we talked about today, was called a variable, and applying the properties of operations to generate equivalent expressions. That means things like commutative, associative, identity, distributive. We've started to talk about some of these words, but we're going to focus on more of them today. And in order to do that, we are going to interpret and analyze equivalent expressions across the board. So let's go through our vocabulary. The first thing we want to be able to identify in an expression is whether we're looking at a variable or a constant. A variable is a symbol for a number that we don't know yet. It's usually a letter like X or Y. So for an example, x plus 2 equals 6. The x is my variable. A constant, on the other hand, is a fixed value. What that means is it's kind of a numerical value that you would typically think of in an expression. So in the equation x plus 5 equals 9, both 5 and 9 are constants. Sometimes a constant is a number on its own, and sometimes it also has a letter attached. That would be a variable that is related to the fixed number, and that's okay too. That number in particular is called a coefficient. So a coefficient is a number used to multiply a variable, like 4x means 4 times x. So 4 is a coefficient. Sometimes a letter stands in for the number. So, for example, ax squared plus bx plus c. X is a variable, a and b are coefficients, and c is a constant. The reason these things are important is so that we can identify like terms in our expressions. That's what we're really going to do a lot of practicing of today. Like terms are terms whose variables and their exponents are the same. So in other words, they are like each other because they have the same variable and they have the same exponent. However, their coefficients can be different. So for example, 1/3 xy squared, negative 2xy squared, and 6xy squared are all like terms because they all have the variable xy, and all of their y terms are also raised to the second power, or r squared. So those exponents are the same as well. When we combine like terms, we want to look at the variables as well as the exponents and follow 3 basic steps in the beginning while we're starting. The first thing I like to do is color code my terms. I want to make sure that any operation prior to the term in the equation travels with it. So for example, under this first example all the way on the left-hand side, I have a 2x plus 4y minus 3x plus 7x minus y. Notice how that first 2x I reorganize and keep with a positive sign in front of it because it is in fact a positive number. Plus 4y stays positive. Minus 3x travels as a minus 3x, and so on and so forth. So first I like to color code my like terms. All of my common variables and common exponents get shaded or highlighted or underlined in the same color so that I can then reorganize. So first I choose colors for my terms. I highlight each like term the same color, and then I regroup them so that all my colors are the same. So for example, in this equation, my 2x, negative 3x, and 7x are all like terms, so I made them all pink. My 4y and my negative y are like terms, so I made them purple. And then I reorganized so that all my colors were together. Then I simplify. 4y's minus 1y would be 3y's, and 2x minus 3x plus 7x would be 6x. So I don't have any more like terms in this expression, so it's simplified as much as it possibly can be. I could do the same thing in terms of examples with exponents and with both varying variables and exponents mixed together. Any equation expression that I look at that has multiple terms will most often have like terms that I can simplify. So don't forget to review your vocabulary. There may be a pop quiz coming up. However, we really want to focus on combining like terms by using variables and exponents. Don't forget to color code, organize, and simplify.